let us learn about cross validation. What is cross validation? Why do we use it? And how to implement cross validation in real life. Let us know all about cross validation. First, let us understand what is a neural network. A neural network is a structure which basically replicates our human brain. It is inspired from our human brain. We want the neural networks to work like a human brain, as smart as human brain, right? Yes. So let us see about uh, introduction to cross validation. Cross validation is a technique used in training neural networks and other machine learning models in order to ensure they perform well on new data. New data here means the test data. That means the data which is not used for training the neural network. It is something new for the neural network. So the basic goal of using cross validation in a neural network is to prevent overfitting. What is overfitting though? Overfitting is a situation which is a result of less generalization and more memorization. That means that the model which we have trained learns the training data too much, so that it includes noise also, and it makes it less effective on new data. It performs well on training data but not on testing data. Foundation of building neural networks. We have 6 topics in this, and let us see each one in detail. First, let us see about network parameterization. The main goal of network parameterization is to transform the raw data into a meaningful model. What do you mean by a meaningful model? A model which can make predictions and classification accurately. Okay? Now, the word parameterization itself consists of the word parameter. In the in the context of neural networks, the term parameter means weight and biases. Let us see what synaptic weights and threshold or bias means. So, synaptic weights are the numerical values that define the strength of the connections between the neurons. Basically, a weight in a neural network determines how much influence the input has on the next neuron. That means the neuron in the next layer. And threshold, which is also called bias, is just an extra value added to the neuron's input before applying the activation function. After the application of activation function, we will get the output. So before applying activation function, we will be adding some extra value to the input. And that extra value we add is called the bias. And this bias helps the neuron to activate, helps the neuron to decide whether to activate or not. In backpropagation learning, the backpropagation learning adjusts the synaptic weights and thresholds, which means biases, in a neural network to learn an input output relationship. The next one is model selection. The main goal of model selection is to choose the best network structure. That means the neural network, has to be neither simple nor complicated. This can be done by understanding how many number of layers our neural network should have, how many neurons it should have, how many connections it should have, and so on. Like if a neural network has too many layers, it becomes too much complicated. And if it has too many neurons, it might be even complicated. And if there is no hidden layer, just an input layer and an output layer, maybe the model is too simple to understand anything. So all these come under the characteristics which decide the structure of the network. And so, how to choose the best network structure? There is a selection criteria, and that is accuracy, complexity, and generalization ability. We always want the neural network to be accurate, the prediction must be accurate, and the generalization ability should be high. The model should be able to generalize the features and understand the given data effectively instead of just memorizing it. Cross validation principle. So, what is cross validation principle? It is a statistical technique, and the main goal for this cross validation is to assess how well a model will perform the unseen data. We can see here that to to ensure that the model is not overfit, we use cross validation. And cross validation means splitting the data into training data and testing data. The training data is further divided into estimation subset and validation subset. What is estimation and validation subset? Validation subset is the data set, the part of the data set which will be used to check which model performs the best. And estimation subset is used to train different models. That is all about the cross validation principle. Basically, to prevent overfitting, we use this cross validation principle, which which states that the data must be divided into training and testing data, and the training data can be further divided into estimation and validation subset. Why validation on different data is important? Let us see. Parameter estimation. It is finding the best values for parameters. Parameters here means weights and biases to make accurate predictions. The motivation behind cross validation is to validate the model on different data which is different from that used for the parameter estimation. So, parameter estimation means finding the best values for the parameters to make accurate predictions. That is itself stating that it is called training. In training, you keep adjusting the weights and biases accordingly so as to get the correct output and decrease the error. So, that is parameter estimation. So, the data which we used in the parameter estimation should be different from the data which you are using to test or validate the model. So that is the main motivation behind cross validation. That is, the data used to validate the model should be different from that of the data used for training. It allows us to assess the performance of various candidate models and select the best one. So when you have okay, two or three models, you will get to choose from the models based on the accuracy you get. So this helps in selecting the model that performs well on the unseen data, which means the test data set. Now let us see about prevention of overfitting. When we are selecting a model, we typically use a validation set to tune hyperparameters. What are hyperparameters? Hyperparameters are different from parameters. For example, the number of layers, the number of neurons, the learning rate of the model, all of these, like the number of epochs used, that means how many times are you passing the data through the data set. More epochs will improve the learning, but more epochs can also result in overfitting. Same like that, batch size, optimization algorithm, what algorithm are you using, all these come under hyperparameter. So when we are selecting a model, we typically use a validation set to tune the hyperparameters. But still, there is a risk that the model may overfit the validation set, meaning it performs well on the validation data but fails to generalize and understand the model. And it might fail to generalize on the test data. So, in order to mitigate this, after selecting the best model based on validation performance, we are going to evaluate the model, evaluate its generalization ability on a completely separate test data. This ensures that the model is not just memorizing the data, but it can also perform well on unseen examples also. So, to prevent overfitting and to understand, to test if the model has really a best fit and it is not overfitting, you will have to first validate the model on one data, which is the validation data, and then test it on an entirely new separate set of data, that is a test set. Okay, so what are the benefits in large networks? Cross validation is especially beneficial when we are designing large neural networks with the aim of achieving good generalization, because large neural networks are often very helpful. For example, the large language models which we use every day, all these are very beneficial for us. So, cross validation is especially beneficial when we are designing large neural networks with the aim that it should achieve a good generalization. That means it is not memorizing, rather, it is understanding the patterns in the data and generalizing it in an accurate manner. It can help determine the optimal number of hidden neurons, the and the best stopping criteria for training. So when you have large neural networks, cross validation can help us where to stop the training. You must have to stop the training at a particular point such that there is no overfitting or there is no underfitting. The model has to be trained perfectly. Finding the balance when to stop is very important. Large networks are powerful, but they require careful tuning. Tuning is adjusting the model's parameters to improve the performance. You should adjust the parameters carefully. Only then the large neural networks can be as powerful as we want them to be.